What the James Webb Telescope just found isn't just another galaxy. It may be the very first of them all, and it's forcing scientists to rethink everything we know about the universe's birth. Just May 2025, the James Webb Space Telescope dropped a cosmic bombshell that's got astronomers everywhere scrambling to rewrite their textbooks. Meet MOM Z14, a galaxy whose light has been cruising through space for a mind-blowing 13.5 billion years before hitting Webb's sensors. We're basically looking at baby photos of this primordial mystery, snapshots from when the universe was just 280 million years old. That's less than 2% of its current age. But here's the kicker. MOM Z14 isn't just breaking distance records. This galaxy is ridiculously dense, crazy bright, and, get this, practically dust-free. That's like finding a teenager's room that's spotlessly clean. This weird detail tells us the blazing light we're seeing isn't from some monster black hole chomping down matter, but from stars being born at an absolutely insane rate. And all this is making astronomers question everything they thought they knew about how the first cosmic structures came to be. To find out more, keep watching. MOM Z14 isn't flying solo out there. The James Webb Telescope is uncovering a whole gang of bright, compact galaxies in the baby universe. Weird little objects with redshifts over 10. Hang tight. We'll explain what that means, that scientists call little red dots. These fresh discoveries are basically giving traditional cosmic models a serious reality check. The old textbooks said the first stars should have taken their sweet time, hundreds of millions of years after the Big Bang, to form, with galaxies coming even later. The story went that matter in the baby universe would slowly clump together under gravity's pull, starting with tiny blobs that eventually merged into bigger and bigger structures. But MOM Z14 and its cosmic cousins are telling a totally different story. This whole process happened way faster than anyone imagined. One astronomer on the research team put it bluntly: JWST is causing absolute chaos in astronomy departments worldwide. Nobody, and I mean nobody, predicted galaxies this mature existing just 300 million years after the Big Bang. Talk about awkward. This bombshell raises some pretty fundamental questions. Did we get the universe's age wrong? Do we actually have a clue how the first stars formed? Maybe not. The discovery of MOM Z14, led by Rohan Naidu from MIT's Kavli Institute, has the scientific team calling it a cosmic miracle, and they're not being dramatic. The name MOM, which we cheekily translate as Mother of All Galaxies, actually comes from the observation program Mirage or Miracle. With a redshift of 14.44, MOM Z14 just demolished the previous record held by JADES GS Z14-0, redshift 14.32, pushing our cosmic time machine even further back. But hold up, what the heck does a redshift of 14.44 actually mean? Redshift, astronomers call it Z because they love their abbreviations, measures how much the universe's expansion has stretched out an object's light waves during their journey to us. Think of it like cosmic taffy pulling. The bigger the number, the farther away and further back in time the object is. For MOM Z14, we're seeing the universe when it was insanely young, hot, and dense. A time when, according to our supposedly rock-solid theories, galaxies this advanced had no business existing. Here's the deal. Redshift works like the Doppler effect, when an ambulance siren drops in pitch as it zooms away. Except in space, it's the fabric of the universe itself that's stretching, pulling light waves longer and shifting them toward the red end of the spectrum. Want some perspective? Our neighbor Andromeda has basically zero redshift because it's actually heading toward us. Cosmic collision in 4 billion years. Mark your calendars. A typical distant galaxy might have a redshift of 0.1 or 0.5. But MOM Z14, this speed demon is racing away at a mind-melting 99.2% the speed of light. That's 185,000 miles per second. Thanks to the universe's ongoing expansion party, this galaxy now sits a whopping 33.8 billion light-years away. Hey guys, before moving on, be sure to subscribe to our channel clicking on the notification bell and leave us a thumbs up so you don't miss out on our daily videos. Features that have scientists scratching their heads. MOM Z14 is serving up a buffet of cosmic weirdness that's making astronomers question their sanity. First up, size. At just 240 light-years across, this galaxy is puny, over 400 times smaller than our Milky Way, which spans about 100,000 light-years. To put that in perspective, it's more like a beefy star cluster than a proper galaxy. Yet somehow, and this is where things get wild, this cosmic pipsqueak packs 100 million times the mass of our Sun. We're talking about a stellar density thousands of times higher than the Milky Way and at least 10 times denser than massive globular clusters like Omega Centauri. What's this tiny powerhouse's destiny? Will it bulk up into a cosmic heavyweight like our Milky Way? Settle down as a respectable dwarf galaxy? Or is it actually the universe's most spectacular globular cluster caught in the act? Your guess is as good as ours. What we do know is that despite its compact size, this thing is blazing like a cosmic lighthouse, pumping out insane amounts of ultraviolet light, the calling card of hot, young, massive stars being born at a pace that would make a rabbit blush. But here's where things get really weird. When astronomers analyzed the light spectrum, basically taking the galaxy's chemical fingerprint, they found heavy elements like carbon and nitrogen. That's like finding a smartphone in ancient Egypt. According to everything we know about cosmic chemistry, these elements shouldn't exist in meaningful amounts so early. The baby universe only had hydrogen and helium straight from the Big Bang oven. Heavier stuff only gets cooked up inside stars through nuclear fusion and scattered into space when those stars go supernova. Finding these elements in MOM, Z14 means, and this is bonkers, this galaxy already burned through at least one full generation of massive stars. Birth, nuclear cooking, explosive death, the whole life cycle, all in under 280 million years after the Big Bang. It's like finding a college graduate at a daycare center. Warp speed evolution that makes no sense. What's really making scientists lose sleep is MOM, Z14's nitrogen to carbon ratio. It's actually higher than our Sun's. This chemical signature matches what we see in ancient globular clusters in the Milky Way, telling us these stars formed in conditions that were absolutely brutal. Crushing densities, violent turbulence, a cosmic mosh pit where stars lived fast and died young. The math says MOM, Z14 reached its current state in just 10 million years. That's not even a heartbeat in cosmic time, more like a nervous twitch. And then there's the missing dust mystery. Baby galaxies are supposed to be wrapped in thick blankets of stellar dust from all those exploding stars. MOM, Z14, clean as a whistle. Maybe the stellar winds are so fierce they're blowing all the dust away like a cosmic leaf blower. Or maybe dust formed differently back then. Or maybe we just don't have a clue. That's what makes this so exciting. Scientists are throwing theories at the wall to see what sticks. Maybe dark matter behaves differently than we thought, allowing faster gravitational collapse in the early universe. Maybe primordial black hole seeds acted like cosmic magnets, pulling matter together at warp speed. Here's another mindbender. What if the early universe was lumpier than we imagined? Regions with slightly more stuff could have collapsed way faster, birthing galaxies ahead of schedule. Computer simulations back this up. Tiny differences in starting conditions can lead to wildly different timelines. That weird nitrogen/carbon ratio is also telling us something huge about how stars formed back then. This chemistry screams extreme conditions, the kind where massive stars producing nitrogen through the CNO cycle had just enough time to spice up the cosmic soup before star formation hit the brakes. But here's the real kicker. MOM, Z14 stars were probably nothing like today's stars. In that nearly metal-free environment, stars could bulk up to insane sizes, hundreds, maybe thousands of times our Sun's mass. These monsters would have lived mayfly lives, burning through their fuel in a few million years while cranking out heavy elements and radiation like there's no tomorrow. Life in the early universe. Time to rethink everything? MOM, Z14's discovery isn't just shaking up astronomy. It's messing with our heads about life, the universe, and everything. If the building blocks for complex structures were already in place when the cosmos was basically still in diapers, what does that mean for life out there? Carbon, nitrogen, oxygen, the whole biochemistry starter kit, might have been ready to rock when the universe was barely 300 million years old. This opens up questions that'll keep you up at night. Did life get started way earlier than we thought? Are there ancient civilizations out there that got a several billion-year head start on us? Or flip it around. Does this cosmic speed run actually mean the conditions for life are even rarer and more special than we imagined? Let's crunch some mind-blowing numbers. Mom, Z14 was already loaded with carbon and nitrogen 13.5 billion years ago. Earth showed up to the party a mere 4.5 billion years ago, with life crashing the scene maybe 3.8 billion years back. Do the math. There could be planets out there with a 9 billion year evolutionary advantage. 9 billion years. But wait, it gets crazier. If heavy elements formed this fast in the baby universe, the first rocky planets could have been spinning around stars when the universe was just 500 million years old. Picture this. While T-Rex was stomping around Earth 100 million years ago, somewhere else in the universe, civilizations might have already risen, fallen, and been forgotten 10 billion years earlier. This cranks the Fermi paradox up to 11. If the universe gave life such an early green light, and some civilizations got billions of years to level up, where the hell is everybody? The possibilities are all mind-blowing. Maybe these ancient civilizations evolved so far beyond us, they're basically cosmic gods we can't even recognize. Maybe they explored everything there was to explore, and then checked out, retired, ascended to some higher plane of existence our monkey brains can't even process. The future, beyond Mom. Z14 Mom. Z14's discovery is just the opening act of what promises to be the greatest show in the universe. If galaxies this mature existed 280 million years after the Big Bang, what else is hiding out there in the cosmic dawn? Astronomers are already drooling over the possibility of finding galaxies with redshifts above 15, creeping ever closer to the moment the first stars flicked on. This is just the beginning of a new golden age of cosmic archaeology. The Nancy Grace Roman Space Telescope, launching later this decade, will have a field of view 100 times wider than Webb's. Imagine going from peering through a keyhole to throwing open the door. It'll spot hundreds, maybe thousands of these primordial galaxies in one shot. Meanwhile, ground-based monsters are rising. The Extremely Large Telescope, ELT, with its ridiculous 39-meter mirror, and the 30-meter telescope, TMT, will zoom in on these ancient galaxies with unprecedented detail. Combining space and ground observations will be like switching from grainy black and white TV to 4K Ultra HD. The ultimate prize? Finding population 3 stars, the universe's firstborn, made of nothing but pristine hydrogen and helium from the Big Bang. These cosmic unicorns would be completely alien to anything we see today. Discovering them would be like finding the universe's birth certificate, signed and dated just moments after the Big Bang. Talk about the holy grail of astronomy. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.